Good afternoon, advanced algebra students. I hope you're doing fantastic. We are now continuing on in our second half of the advanced algebra book, but what we are going to do is a little detour back to Algebra 1 just to review how to solve systems of equations. We did talk about solving a problem by graphing in our last lesson. What we're going to do today is talk about solving a system by graphing. So system is just a fancy way of saying more than one equation. So we are going to, in our, when we go back to Algebra 1, we're going to look at solving systems by graphing, elimination, and substitution. So this is our first lesson, 4.1, solving systems by graphing. Now, what I'm going to do is show you three basic types of answers that you can get when you're trying to solve a system. A solution to a system simply means where do the lines touch? Where do the lines cross? So let's do an example here where we have two lines. One is y equals 1/4 x plus 1, and the other one is a negative 3x plus 2y equals negative 8. So we're going to go ahead and graph the first line. The first line has a y-intercept of 1 and a slope of 1/4. So we're going to go up 1 and over 4 and draw that line in. And then the second line is not currently in slope-intercept form, so we're going to add 3x to both sides and then divide by 2. When we do, we see that this line has a y-intercept of negative 4 and a slope of up 3/2. And so the two lines do cross, and they cross at the point 4, 2. Now in our last lesson, we were also looking at where two lines cross, but because our original equation only had an x in it, we were only looking for the x coordinate of where those lines crossed. In this particular case, our system includes two equations, and both equations have two variables. So our answer is also going to include two variables because we're talking about both the x and y coordinate here. So the answer is the point 4, 2. These lines cross at the point 4, 2. Now, there are two other possibilities that can happen when you're working with systems. The first one, of course, is that the lines cross at one point. Let's do another kind of example. We have y equals 5 minus 3x, and then 15x plus 5y equals 25. Again, we want to graph both lines. So the first one has a y-intercept of positive 5, and then a slope of negative 3. So let's see, we're going to go down 3/1 and then down 3/1 again. Now, in order to graph the second line, we want to subtract 15x. So we're going to have 5y equals negative 15x plus 25. And then when we divide by 5, we get y equals negative 3x plus 5. Notice that that is exactly the same graph that we just graphed. We have a y-intercept of positive 5, a slope of negative 3, and I'll try to make this pink line kind of thick so it's easier to see, but you can see that these are exactly the same line. So what do you think the solution means in this case? Since solution to a system means where the lines cross, and the lines are exactly the same line, they cross everywhere, right? They touch everywhere. So our solution in this case is infinite number of solutions because they are exactly the same line. Okay, scenario number 3. Let's say that our equation is, first one, negative 4x plus 2y equals 8. And then for the second one, y minus 2x equals 6. Let's go ahead and do the second one first. If I add 2x, I get y equals 2x plus 6. Here, if I add 4x, I get 2y equals 4x plus 8. And then when I divide by 2, y equals 2x plus 4. All right, let's graph them. The first one has a y-intercept of 4 and a slope of 2. The second one has the y-intercept of 6 and also has a slope of 2. So notice here, in example 2, we had the same slope and the same y-intercept. In example 3, we have the same slope but different y-intercepts. So what's happening here is that these lines are exactly the same. These two lines have the same slope, but because their y-intercepts are different, they're not the same line, they're just parallel lines. So this is a very different situation. Here, the lines touch everywhere. Here, the lines do not touch at all. So where this is infinite solution, this system is going to be no solution. Okay? All right, so we've done kind of the 3 basic examples. I did want to do one word problem with you to help you get ready for the homework as well as any upcoming assessments. And that should wrap up our brief review of solving a system by graphing. So this will be example number 4. Now I am going to read you the word problem. You don't have to write it all down. All you need to write down is what I'm putting on the board. I am drawing a graph where the y-axis is labeled by skip counting by hundreds. And then the x-axis is skip counting by 2s. And on the x-axis, I think I went out to 18. So 2, 4, 6, 8, 10, 12, 14, 16, 18. All right, I'm gonna read the problem and then we'll write down the equation together. Monisha is considering 2 catering companies for a party. Best Food Ever charges $25 per person and $80 to set up. Divine Diner charges $30 per person with no setup fee. Write and solve a system of equations to represent the charges for catering by each company. What does the solution of this system mean, and what is the solution? Which company should Monisha use if she expects 20 guests? Okay, so let's kind of think about this. We're gonna make X be the number of people, and we're going to have Y be the cost. For Best Food Ever, because they have a $80 setup fee and $25 per person charge, our total cost is going to be 25 times how many people we have, plus that $80 setup fee. So for example, if we graph this line, we have a y-intercept of 80, and then we go up 25 over 1. I just did a couple points here. If you figure, for example, if there's 10 people, we would put 10 in for x and get 250 plus 80, or 330. So when x is 10, our y value is going to be 330. And then I also put in for 16 people, the cost would be 480. So I went over to 16 and up to 480. So the Best Food Ever line is going to look like that. And then for Divine Diner, our equation would be just simply y equals 30x. So the x-intercept there is going to be 0, and then we're going to go up 30, over 1. If we put in a couple points, for instance, at 10 points, 30 times 10 is going to be 300. So we would go 10 over and 300 up. And then at 480, the cost, at 16 people, the cost is 480. So the line there is going to go like this. And I apologize that I'm not using a better ruler here. Let's see if I can make this a little straighter. Okay, that should be good for now. Not the best line ever, but it works. Okay, so what we can see is that the cost is exactly the same where x is 16. However, this line represents the first line is Divine Diner right here, and the one on the bottom is Best Food Ever. You can see that up until 16 people, it is going to be cheaper to work with Divine Diner. But after 16 people, it is going to be cheaper to work with Best Food Ever. So the question asked us, what is the solution of the system? The solution would be the point 16,480. What does that represent? It represents the cost, represents the fact, I should say, that when 16 guests are invited, the total cost is the same. And then the last part of the question said, if Monisha is going to expect 20 guests, who should she work with? The answer would be Best Food Ever. So for 20 guests, Monisha should work with Best Food Ever. All right, hopefully that was helpful. I'm looking forward to seeing you in Zoom. Bye, guys.